Hello everyone, I hope you are doing well. So in today's video, I'm actually going to go through the 2018 Maths Methods Exam 2 extended response questions. To be honest, I just want to get these questions done because I have work tomorrow and I gotta, I just, promised myself that I'll finish this paper right now. So yeah, I want to smash through this paper and yeah, hopefully that's that. Guys, again, if you guys want private tutoring, you can always email me down over this email. It's always in the links in the description. Email me, we can have a discussion. And yeah, I tutor physics, chemistry, physics and specialist mathematics. Let's get through this video. Let's go. Question 1. Consider the chord this, f of x is this, and part of the graph of f of x below. Find the coordinates of the point M, at which the minimum value of the function occurs. Okay, so I'm going to define the function. So f of x, f of x defined to, so 3x to the power 4 plus 4x to the power 3 minus 12x squared. All right, so we want the actual minimum value. So we go on, calculus, minimum value of f of x, comma x, and it occurs at x equals 2, perfect. So what's f of -2? And here's your x value and your y value. Let's write that down. So we can say -2, -32, done. State the values of b for which the graph of f of x plus b, so it's b is a translation up or down, has no x-intercepts. Okay, so remember that this point over here, the one that we got, which is, it occurs at -32. If we translate it, like b equals 32, we will up this graph to this. It'll be like this. This point over here, so this point over here would be over here, and it'll go like this. Blah, blah, blah. So, and if we go up and up, so what's b equals 33, we will get this graph up, and if that happens, we will get no solutions and no actual intercepts because it won't cross. Perfect. So what we want is just where b is greater than 32. Perfect. 32. B should be greater than 32. Yeah. Because and by the way, it cannot equal 32 because if it does, that is one. We don't want no x-intercepts. But yeah, if you do that, if we let it equal, it will actually give a value. So be careful. Make sure it's b is greater than 32. And yeah, and it will give any values, and it will never touch the x-axis. Perfect. Luckily, that helped us. We didn't have to use our calculator. Perfect. Part of the tangent L to y equals f of x at x equals this is shown. Find the equation of its tangent. Easy. So go on menu, calculus, tangent line of f of x, comma x at -1 or 3. Perfect. This is your equation. Let's write that down. Y equals 80 over 9x plus 41 over 27. The tangent L intersects f of x at this and two other points. Yes, right over these 2 points. State the values of x. State the x values of the 2 other points of intersection. Express your answers in this form, where a and b are integers. Okay, so what we want is we want f of x to equal 89x plus 41 and 27. So let's do it on calculator. So what's f of x equals this over here. We want to solve answer comma x. So it's these 2 values over here, and if we want it in that form, so it'll be -1. Let's write that. So it'll be your x will be -1 plus or negative square root 42 on 3. Done. Is that right? -1. Yes, perfect. All right, so just highlight this. Okay, to go down. Find the total area of the regions bounded by the tangent line. Y equals f of x. Express your answer in this form, where a and b are positive integers. Okay. So we want, this area. Perfect. So we can just say -1 minus 42 on 3 to -1/3 of the line 80 on 9 x plus 41 27 minus f of x dx plus -1 1/3 -1 plus 41 on 3. What's the upper function? Still L. So we can say 80 over 9 plus 41 over 27 minus f of x dx. Let's just move this a little bit over here. Writing this in our calculator, we should get the value. What's that? Let's do that. So we're saying integral of this value over here to -1 over 3 of this over here minus f of x dx plus the integral -1/3 to this value over here. Copy this whole function, paste it over here, dx, and that gives you this value. So let's write that down. So 7, 8, 4, 42 over 135. And yes, it's in the right form. That's good. Move on to the next question. So p of x is this, where a is an element of all reals. State the values of a for which f of x equals p of x. So let's actually define p of x. So 3x to the power. So I think, yeah, so it's the same as the f of x, but it's in a different, like there's something different about it. Like it has a's and stuff. But yeah, that's no problem. We'll a minus 2 times x squared minus 12a times x plus a squared. Is that right? Just double check it. Plus 6a minus 6. So perfect. State the values for where f of x and p of x equal. So f of x equals p of x, and we want to solve answer for value of a. So pretty much a equals 0 because it says state the value for which f of x. This over here, yeah, it has x's, so that's not good. Just put this point over here. A equals 0. I think that should be the answer because it says state the value of a. So yeah, just put a equals 0. Don't put the other one because this one over here, it's actually, yeah, it has x's. Find all solutions to p dash of x equals 0 in terms of a where appropriate. Okay, p dash of x, so should minus of p of x equals 0. We want to solve answer comma x. And here we go. So find all solutions to this. Okay, so at x equals 1, at x equals -1 plus 1 minus a, and at x equals -1 plus 1 minus a. Oh, I'm supposed to put a minus on one of them actually. Let's put a minus over here. Perfect. Find values of find the values for a. Find the values of a for which p has only one stationary point. Okay, look at this. Well, we already have one stationary point over here. That's one solution. We want to make sure that these two don't exist. And one way we can do that, because they have like 1 minus a, is we know that when there cannot be a negative number in a square root. So what about if we say the inside, so 1 minus a, is less than 0. We want to make it negative. Again, we don't want to let it equal like less or equal, because if you let, it means pretty much if the square root equals 0, we'll get a solution called be just -1. So be careful, just less than 0. And solving that, we get -a is less than -1, so a must be greater than 1. Yeah, so a must be greater than 1. Find the minimum value of p when a equals 2. Okay, so what I'm going to do over here is I'm just going to say, what's p of x given that a equals 2? So it's this equation, so I'm just going to say menu calculus minimum value of this whole function, comma x. And our minimum value is at x equals 1. Oh, no, at x equals 1, but we want the minimum value. So it will be this function, put that value over here, so -13. So your min value, -13. If p has only one stationary point, okay, so we know that one stationary point a is greater than 1 for it to have a stationary point. So if p has only one stationary point, find the values of a for which p of x has no solutions. Has no solutions. Okay, if we go up, this was similar to this question, one of these questions over here. So find the values for which has no x-intercept. No, not. So, yeah, so it has no x-intercept. And find the values of a for which p of x has no solutions. So no actual intercepts when p of x. Okay. All right. Well, for this one here, if we look over here, we just found that minimum value, and we let it greater than 32, and we let the, so like the y value of the minimum, we said it's greater than the y value of the minimum. That's what we just did. So if I'm not mistaken, we should do the same for this too, because they are the same equations. If you really look at the structure is the same. But yeah, we have 8. So what I would say is, do we have, so find solutions where appropriate. Okay, let's say that, okay, p of x, let's go and calculate and say menu calculus minimum value of p of x. So what's the minimum value of p of x, comma x? And it's these ones over here. What I'm going to need to do, I think, is I will just do something. So if I just come to this, Control C, and really create a new document, new problem actually, so I don't mix those up, and kind of graph this over here. If I graph this with this value of a, and we said, okay, we want to be careful. So if we go up and down, a is, yeah, we said a must be greater than 1 because we have one stationary point. What can we see? Well, let's put this to 10. Well, there's only one, like, we want this minimum value, which occurs at x equals 1. Yes, so at x equals 1, which we've already calculated. Let's go back to our, so at x equals 1, so we can say that when p of 1, that y value, because we remember we're doing the same thing as we did here. We said this, and we said it's great, wait, here. Yeah, and it's greater than that value. So what's p of 1, actually? So p of 1, we go back to our old, so what's p of 1? It's this, so it's a squared minus 6a minus 5. And we want that to be, we want that to be greater than 0. So we want p of 1. What am I doing? So a is greater than, so p of 1 equals a squared minus 6a minus 5. If I, okay, and we want this value to be greater than 0, so a squared minus 6a to be greater than 0, because we cannot let it equal 0, then we'll get one solution. So if we do that, so solve, answer greater than 0, comma a, we get these two. We can only take a is greater than this, because if a is less than that, we can only take a as positive, because we said for one stationary point a must be greater than 1. So we can only take this positive value here. So yeah, hope that's right. So a is greater than root 14 plus 3. I need to double check actually. Is that right? So the way I'll check is go back over here, and we said that a is the square root of 14 plus 3. And it should be, what the hell did I do? Square root of 14 plus 3. Okay, perfect. Yes. So, but we're saying it's not equal. It's greater. Yes. And if it's greater, perfect. It never actually touches it. So yeah, that's that. That's a way to double check it by just pretty much putting those values in. Question 2. A drug X comes in 500 milligrams tablets. The amount of B of a drug in the bloodstream in milligrams T hours after one tablet is consumed is given by this function. And by the time in hours it takes for the, so find the time in hours it takes for the drug to reach a maximum amount in the bloodstream after one tablet it's consumed. Express your answer in this form. Okay, not too bad. So just let me control N this and create a new document. So let's define the function. So we're saying B on T is defined as 45007 times E, so negative T over 5 minus e negative 9t on 10. Okay, we get this. And so we want to find in terms of hours. So, okay, so go on menu, go on calculus, and go to, we said maximum. Yeah, so maximum of b on t, comma t. So this is your maximum. Perfect. Let's write that. Because it's 2 marks, what we're just going to do is, let's just b dash, just try to find b dash of t to show that we've done some working out when it's equal to 0. So b dash on t is what? So let's just do that. So dx b on t, make sure that's t actually. And we get this. So we're saying negative 4, 50 e negative 9t on 10, 2e 70 on 10, minus 9 all over 7 equals 0. So t must equal 10 on 7 log e 9 on 2. Did we write in the form? So express your answer in form where a and c are all reals. Yeah, that's that. Perfect. Let's look at the next question. The graph of b on t is shown from 0 to 6. Find the average rate of change of the amount of drug in the bloodstream in milligrams per over this interval. Okay, so we just want to find what is b of 6 minus b of 2 all over 4, which we can do in our calculator. So what's b of 6 minus b on 2 on 4. Control enter to 1 decimal place. That's negative 33.5. Yeah, 0.5 milligrams per hour. That's that. Find the average amount of drug X in the bloodstream in milligrams during the first 6 hours after the tablet is consumed. So be careful here. Average amount, not the average rate. So here is the average value. So we're saying what's the average value from 1 to 6 hours. So 6 minus 0, from 0 to 6 of b on t dt. Let's do that in our calculator. So 1 on 6 integral from 0 to 6 of b on t dt. Control enter, and we want it to the nearest milligram, so it's 256 milligram. Done. 6 hours after the 500 milligram tablet of drug is consumed, a second identical tablet is consumed. The amount of drug X in the bloodstream from each tablet consumed independently is shown. Okay. On the graph above, sketch the total amount of drug X in the bloodstream during the first 12 hours after the tablet is consumed. So, okay, we're just adding. This is just addition of this to this point here. All right. Well, at this point here, at least they're not adding. So we can just redraw this nicely. Okay. How would I... Well, to be safe, I'm just going to do it on a calculator and just sketch it. So I'm just going to go on graphing and just say... I'm going to draw a hybrid function, actually. That's the most easiest. So if I say a hybrid function of two functions, so let's say first is the b on t from the... It's the first tablet, which goes from 0 to 6. 0... well, we'll write it in terms of x, actually. 0 to 6. And the other one is, think of it, it's been translated 6 units to the right. So we can just say bx minus 6, sorry, because it's translated to the right. But remember also that we're adding another b on x, because, yeah. So we're trying to add that from 6, let's say equal to x, to 12. Enter that. Oh, menu, graph, fit. Okay, perfect. So, and I'm just going to make this nicer. So if I go on view, actually Windows setting. Okay, so your x minimum here should be 0. Your y minimum is 12. Your auto scale by 1, let's say. Our y value is from 0. Our y max is 500. And the scale goes by 100. Okay, we do that. Also, what we can do is if you can go to view, actually, and we can go grid, and we can go line grid. Perfect. Just pretty much recopy this whole thing, what we've just done over here. So that, and so the maximum value. So, okay, if I just go on graph trace and make my life easier. So let's say at 0.7. So if I write 7, enter. So 7 is 422. So go on my thing. 422, which is approximately here. What about 8? 454. So around here. What about 9? 9. 416. What about 10? 358. What about 11? 300. And what about 12? 250. Around here. And just to double check, what's 6.5? At 6.5, it's 350. Somewhere around here. Perfect. So drawing this on top of this nicely. That's that. Yeah, that's the addition of it. Addition of ordinates. Just, yeah. Okay. On the graph above, sketch the total amount in the first blah, blah, blah. Okay. When find the maximum amount of drug X in the bloodstream in the first 12 hours and the time at which the maximum occurs, give you answers to 2 decimal places. So this maximum over here. How would I do that? Well, because I have the equation actually on my hand now, luckily I have it over here. I'm just going to copy this equation and really go over here and say, let's make an equation out of it. Let's say it's g of x. Let's make this as a new function. So g of x is this function, and we want to find the maximum. So go menu, calculus, maximum value of g of x, comma x from 0 to 12. And this over here is your x value, which it occurs. So let's write that down. So, all right. So actually your t value, sorry, make sure it's t. So it'll be t equals to the decimal place, that's 7.78. And the max value, so if we write max value, occurs when g of this function over here. Control enter that, we get this over here, this number. So to 2 decimal places, that's 455.82. Done. Milligrams. Next question. Question 3. A horizontal bridge positioned 5 meters above level ground is 110 meters in length. Yep. The bridge also touches the top of the 3 arcs. Each arc begins and ends at ground level. The arcs are 5 meters apart. Okay. At the base, as shown in the diagram, let x be the horizontal distance in meters from the left side of the bridge, and let y be the height in the meters above the ground level. Arc 1 can be modeled by the function this, from 5 to, okay. Arc 2 can be modeled as that. Arc 3 can be modeled by this. Is that the value of a? Okay, so we don't know what this is. Well, just have a look at this, actually, before I define it. So when it's here, this value is 5, it occurs over here for the first arc. When it's 40, it's this arc over here. When it's a, it should be at this point over here, which is, so a should equal 75 by just having a look at the pattern over here. So yeah, let's define these 2 functions, these 3 functions to make our life easier. So control in this, and yeah, let's say h1 of x is defined as 5 sine pi times x, pi times x minus 5, oops, let me just put it over 30. So h2 of x is defined as, copy this whole thing, the difference is, it's just this value is 40. So h3 of x is defined as, copy the same thing, but this now is 75. Done. So we have all these. Describe the transformation that transforms the graph of h2x to h3. So this graph over here, this arc over here, this over here. Okay, so it's just a translation. Well, it starts over here, 40, and we want it to move to this point over here, which is 75. So 75 minus 40, which is 35. Yeah, translate it 35 units to the right, and we should get that. So we translate that, and yeah. So we can just say translation of 35 units in the positive x-axis. That should give the mark. Okay. The area above the ground level between the arches and the bridge is filled with stone. The stone is represented by the shaded area region. Shaded regions is shown below. Find the total area of the shaded region correct to the nearest square meter. Okay. Because they have the same shape. If I can find the area of this one and multiply by 3, we'll get these 3 areas over here. And then if I can find the area of this rectangle over here and minus it by these 3, we should actually get all of this area over here, which we want. So yeah, let's do that. So that's what we want to do. So what is the area of the rectangle first? Let's try to find that. Area of this rectangle is area is, well, it's 110 times 5. So let's do that. 110 times 5. So that's 550 here. And we want to find the area, but 3 times it, remember? So we want to find the area of 3 times it. Let's say for the first function, which is just 5 to 35 of h1 of x dx. So it's 3, 5, 35 h1 of x dx, and that gives you 900 pi. And we can say, so what's 550 minus 900 pi? Okay, let's do that. So what's 550 minus this value over here, and to the nearest square meter, this would be 264 meters squared. Have I done everything right? Find total, so I've multiplied that by 3. Find total, yeah, should be good. I hope that's right. A second bridge has a height of 5 meters. So a second bridge has a height of 5 meters. Okay, the ground at its leftmost point and is inclined at a constant elevation of 5 pi over 9. Okay, as shown in the diagram below. The second bridge also has 3 arches below it, which are identical to the arches below the first bridge and spans horizontal distance of, okay, let x be the horizontal distance in meters from the left side of the bridge, and let y be this. Set the gradient of the second bridge to 3 decimal places. Okay, so we're just trying to find the gradient of this. This is very easy. Because we're given the angle, you should know it's the gradient. Yeah, so we know this point over here. So we can just say gradient is just tan of the angle, which here is pi on 9, 90. So let's do that. So what's tan pi on 90? It's this value to 3 decimal places. That's 0.035. Yeah, 3 decimal places. So let P be a point on arc 5. Let me just rub this off. So the point P is this point here. So let P is a point on arc 5. The tangent to arc 5 at point P. So let's say this tangent, well, has the same gradient as the second bridge. So the tangent should have the same gradient. So it would look like this actually. So if they have the same gradient, find the coordinates of P. Okay, so it's arc 5. So because we know the gradient of Q, so like this one over here, because we know they have the same gradient, we can say, what's the derivative of h2 of x? So h2 dash of x is what? So h2 of x, let's find the derivative of that. It's this, so we can write negative pi sine pi x 30 plus pi 6 over 6, and we want to equate that to 0.035, the gradient of that, and calculate the value of x. So you can want to say solve this over here equal to this value over here, comma x. Oh yeah, we want to be careful. We want to give a domain, because yeah. So we're going to say from 0 to 110. Okay, control enter. So So the tangent should be between 40 to 70, so it can only be this one over here. So choose that. So that's your actual x value. So that's our x value. So, and what's h2 of that this value over here? Control enter. Okay, that's it. So our coordinate of P is 54.2 decimal places. So 36, 4.98, 4.99 actually. Yeah, two decimal places. Is that right? Yeah, it looks good. Perfect. 4.99. A supporting rod connects at point Q. Okay, let me just drop this. So this is a supporting rod over here. A supporting rod can connect at point Q on the second bridge to point P. The rod follows a straight line and runs perpendicular to the second bridge as shown in the diagram. Find the distance PQ in meters. Okay, so perfect. So these over here, they connect. And we're trying to find the distance between them. Well, we know the value of P luckily, but what about value of Q? Well, we know the gradient of this over here, this line over here, which is what? Well, it's tan pi on 90. That's a gradient. So the perpendicular gradient. So the perpendicular gradient is just over -1 over that. So that's your gradient, which goes now like this. And we know that passes through the point P. So we can say y minus, so y minus this value over here. So y minus 4.9888. To be safe, I just want to make sure, 68 equals -1 over tan pi 90 x minus 54.36265, and so y should equal what? So let's just calculate that. So solve y minus this value equals -1 tan pi 90 x minus this value over here, comma y, and we get this over here. Let's write that down. So -28.63625 x minus 54.53687, and so we have this. To find coordinates of Q now, it will be, so we have now this graph. Now we have this line over here. We just need to find where it intersects the same gradient as Q now. Well, we know that gradient is just tan pi on it. Yeah. So what's the derivative of this then? What's dy dx? And we want that dy dx to equal tan pi 90, and we should find that value of x, and that gives you the value of x for Q. So we want to say derivative of the respective x of this function over here should equal to tan pi 90. Oh, what's here? Okay, just let's have a look. So this, enter that. Well, what's happening here? So wait, we have this equation. Wait, what's happening with me? Okay, so we have that equation. So we have the equation of this. Okay, so we have this equation. Let's find this equation over here. because we know it passes through 0. What about, so this is 0, 5. We know the gradient's 10 pi 3. It's just y minus 5 equals 10 pi 90 x minus 0, which is just x. So y equals 10 pi 90 x plus 5. So this equals this over this here, and we should get Q2. So let's do that. Okay, so that equals 10 of pi 90 x plus 5. Is that right? Yep. And we want to solve that. Answer, comma x. And we get this value over here. Yep. So that should be Q. Yeah, so that line should be Q now, because that's where they should be intersecting. So yeah. So that point is Q. So the point Q is, let's write the coordinates. So it's, let's say, right, 54.29605, and the y value for it is, we can just use any of these. Let's take this one over here. It's 6.89606, and it's very easy to calculate the distance. It's just square root of all of these. So 6.89606 minus the value of 4.99 squared plus 54.29, let's say 6, minus 54.36. 54.36 squared. So d must equal what? I'm just going to do on my calculator with the exact value. So square root of this over here minus 44.9. Then we're going to go up this one over here, and we're going to square that, plus, oops, so plus this over here minus this over here, and let's square it. Control enter, and this is your value. Wow, that took long. 2 decimal places, that's 1.9. 1. Yeah, that's that. That's your distance, actually. Question 4. Doctors are studying the resting heart rate of adults in 2 neighboring towns, Mathland and Statsville. Resting heart rate is measured in this. The resting heart rate of adults in Mathland is known to be normally distributed over this and the standard deviation of this. Find the probability that a randomly selected Mathland adult has a resting heart rate between this and this. Give your answer to this. Okay, so Control N this whole thing and just go on. Okay, menu. We're dealing with normal, so we're going to go normal CDF, and our lower bound here is 60, and our upper bound is 90. Our mean value is what? 68, and our standard deviation is 8. Done. There we go. This is our solution. So let's write that. 0.23 decimal places. That's 0.838. Done. The doctor's considers a person to have a slow heart rate if the person's resting heart rate is less than this. The probability that a randomly chosen Mathland adult has a slow heart rate is actually this. It is known that 29% of Mathland adults play sports regularly. Okay, it is also known that 9% of the Mathland adults play sport regularly and also have a slow heart rate. Let S be the event that a randomly selected Mathland adult plays sport regularly, and let H be the event that randomly selected Mathland adult has a slow heart rate. So what's the probability of this? Okay. So we're trying to find the probability of H intersection S over the probability of S. So we want where his heart rate is slow, and also he plays sport. So it is also known that 9% of the adults play sport and have a slow rate. Yeah, so 9%, so we can just say that's 0.09 over where they play sports regularly, which is 29. So 0.29, they've given you everything here. Let's write that. So 0.09, 0.29, and that gives you to 3 decimal places, that's 0.310. Are events H and S independent? So are we saying that the probability of H times the probability of S should equal the probability of H intersection S? Is that true? Well, What can we know? Okay, our event, so we have the intersection, we have S. We also have so if a poly that randomly chosen math line adult has a slow heart rate. Okay, so we have 0.09, so we have, wait, so the probability of S is what? 0.29, so we can say 0.29 times the probability of S, so having a slow heart rate is over here, so 0.1587, is it equal to the probability of H intersection S, which is 0.09. Is that right? So let's double check that. Let's say it's 0.29 times 0.1587. Is it this? No, they're not equal. So we put a non-equal sign. So they are not independent. Yeah, that's right. Find the probability that a random sample of 16 math line adults will contain exactly one person with a slow heart rate. Okay, so we know that, let's say X is binomially distributed. We know that there's 16 people and we want slow heart rate. So the probability was what? 0.1587. 0.1587. So we want the probability that will contain exactly one person. So X equals 1. Doing our calculator. So X, probability, distributions, binomial PDF. Our number of trials is 16. Our probability of success is 0.1587. Our X value is 1. So it's this. To 3 decimal places, that's 0.190. What's that? Next question. For a random sample of 16 math line adults, P is the random variable that represents the proportion of people who have a slow heart rate. Find the probability that P is greater than this. So we want the probability that P, this, is greater than 0.1. So we know that P is equal to X over N. So we're saying the probability that X is greater than, so we put 0.1 equals X and the number of people is 16. So what's 16 times 0.1? So 16 times 0.1, that's 1.6. So 1.6. Now, because it's binomial distributions, we know it has to be a full number. So we have to say probability that X is greater or equal to 2. And that's easier now. So let's do that in our calculator. Go on menu, probability distributions now, binomial CDF, and 16, probability of success is 0.1587. Okay. Lower bound is 2, upper bound is 16. And we get this value over here. So to 3 decimal places, that's 0.747. Done. Let's do this one. For a random sample of n math line adults, Pn is a random variable that represents the proportion of people who have a slow heart rate. Find the least value of n for which this is greater than 0.99. Okay, so we straight away, let's just make this 2. So probability that, let's say X is greater than what? So we know that P this is 1 X on N. So we know N, we don't know N, but our P value is 1 over N. So we multiply by that by N, and that gives us X. So these cancel out. X is equal to 1. So we put 1 over here. So this, we're saying is greater than 0.99. Now we can say that 1 minus the probability of X is less or equal to 1. It should be greater than 0.99. That's true. So minus probability that X is greater or equal to 1 is greater than negative 0.01. Probability that X is greater or equal to 1. The signal will change because we're dividing it by negative, so it'll be less by 0.01. So this is now easier to use in your calculator. So we can use the function. So go on menu, probability distributions, and go to inverse binomial n. Our cumulative probability is 0.01. Our probability of success is, what was it? 0.1587. Our success number is 1. Okay, gives you 39. So your n value is 39. Yep, That's that. But you need to get it in this form, by the way, guys. Make sure to have it in less than. So like probably if x is less than 1. So I couldn't use it for this. That's why I had to kind of use these steps to change it to that. Yeah, that's the answer. The doctors took a large random sample of adults from the population of Statville and calculated an approximate 95% confidence interval for the proportion of Statville adults who have a slow heart rate. The confidence interval they've obtained was this. Determine the sample proportion used in this calculation for this confidence. Yes, this is a typical question. I think it was in the Northern Hemisphere, I believe, one of the Northern Hemisphere exams. Very easy. So if you are given the actual confidence interval, if you can just draw yourself a normal nice distribution graph, your actual proportions P here, and these values over here are equal in distance. So this over here is here, and the other one's over here. So to get, so if this is 0.145 here, and this is 0.102 here, how do we get P? Well, we add them and divide them by 2. So let's add them. So 0.145 plus 0.102 divided by 2 should give you your P value. So let's do that. What? 0.145 plus 0.102 divided by 2, that gives you 0.1235. That's your answer. There. Okay. Oh. This is, yeah, I just want to get this exam done. Okay. And that's your equal to your p-value. Or, yeah, proportion. So explain why this confidence interval suggests that the proportion of adults with slow heart rate in Statsville would be different from the maths one. Of course, yeah. Well, look at this confidence interval over here. So that's for this one's for Statsville. So if we go on top, does the slow heart rate, where is it? Does this slow heart rate in where is it? In maths land. So does this fit inside the confidence interval? So what was it? 0.15. Let's say 0.16. No, it doesn't. So we can say that the proportion, so proportion of Mathland adults who have slow heart rate, so proportion of Mathland of adults who have slow heart rate, are not within the confidence interval of Statville. All right. Yeah, so this question, I think it also came up in one of the exams. Yeah, there was a similar question to this. So yeah, if you see these kind of questions, make sure to look at their confidence intervals. Do these confidence intervals fit within each other? And that's, yeah, you just have to write something like a basic question like this. Every year at Mathland Secondary College, students like to hike to the top of the hill that rises behind school. The time taken by the randomly selected students to reach the top of the hill has the probability density function this. When t is given in time, find expected time in minutes for a randomly selected students from Mathland Secondary College to reach the top of the hill. So expected time. Okay, so we want expected value of m. It's very easy. It's just 0 to infinity, 3t 50 t on 50 squared e t on 50 3 dt. Remember, I multiplied by t to get the actual value. So let's define this. So m1t is defined from, so it's defined as well. Oh, let's actually, it's just 3 over 50 times 2 over 50 squared times e. Oops. power negative t50, so t50 to the power of 3. Okay, so to do the other one, so we're saying from 0 to infinity, t times mt dt is, control enter this value over here. So to the 1 decimal place, that's 44.6. Students who take less than 50 minutes to get to the top of the hill are categorized as elites. Find out probably that the randomly selected students for Mathsline Secondary College is categorized as elite for decimal places. Okay, so to be categorized as elite, we want the probability of less than 15. So from, well, just let's write this as this. We want 0 to 15 mt dt. Let's do that in our calculator. So we want 0, 15 mt dt. Control enter. So it's this probability. To 4 decimal places, that's 0.0266. Yeah. The Year 12 students at Mathsline Secondary College make up 1/7 of the total number of students at school. Of the Year 12 students at Mathsline Secondary College, 5% are categorized as elite. So, okay. Find the probability that a randomly selected non-Year 12 student at Mathsline Secondary College is categorized as elite. Give your answer to this. Okay, well, just draw a tree diagram over here. So let's say that this guy's in Year 12 and non-Year 12. And they are elite, non-elite. Elite, non-elite. And we know that 1/7 are Year 12s. So the other ones will be 6 on 7. We also know that of the Year 12 students, 5% are categorized as elite. So we can say that's 0.05 and this is 0.95. And we don't know the other ones. Find the probability that a randomly selected non-Year 12 student. So we want to find probability. So 12- intersection is as elite. We want this. We just calculated over here the probability of elite, of just being elite. So what we can actually do, so we can say the probability of being an elite is what? We've already calculated, yeah? It's this value over here. Is equal to what? The probability of being a Year 12 intersection elite plus the probability of being a non-Year 12 intersection elite. And this is what we want over here. So let's make an equation. So we know that probability is what? 0.0266. And that's equal to your probability of 12 times 12 intersection E, which is 1/7 times 0.05 plus 6 on 7 times x, because we want to find this over here. It's non-binary. That's our x value that we want to find. So 6 on 7 x, that will give us the probability that a randomly selected non-Year 12 student. Yeah, so we want x. So now doing this in our calculator, we can say solve. This value over here equals 1/7 times 0.05 plus 6/7 times x, comma x. X value is this, so that's your probability. So x should be, to further subplaces, that's 0.0227. Yeah, that's that. Is that right? So find the probability that a randomly selected non-Year 12 student at Mathsline College is categorized as elite. Yeah. Perfect. Question 5. Consider the functions of the form this and this, where a is a positive real number. Find the coordinates of the local maximum of f in terms of a. So let's define these. So control N this now. And let's define these. So f of x. Damn, I'm very tired actually. Wow. Just want to get this. Is this the last question? Yeah, it is. So yeah, let's smash through this one out. X squared times a minus x 4a squared, 4a to the power 4 actually. And g of x is, oh, h of x, sorry, what am I saying? H of x is defined as 9x over 2a squared. Done. So find the coordinates of the local maximum of f in terms of a. So if we go menu, calculus, local maximum of f of x, comma x, where we know a is a positive real number, so we can just say a is greater than 0. Enter. Oh. Okay, why does it give me that? What about if I take this a value? Control enter. Ah, it's not giving me anything. Okay, so we have to do the manual way. So let's go shift, so find the derivative of f of x first. And let it equal to 0. And we want to solve that for x. So these are the two values over here. But we want to be careful. So it says find the coordinates of the local maximum of f in terms of a. We don't know which one's the maximum and minimum. And there's a quick way to do it. It's actually using the double derivative. So if I go in this, because yeah, so if I use the double derivative of f of x, yep, so it's this. And let's, okay, if we want to find the maximum, we want the value. So let's try to check if this value over here is a maximum. No, it's a positive value. Remember, a is greater than 0, so this is the whole function over here is positive. So this, when x is equal to 0, that's a minimum value. So let's double check the last one, which was this over here. Aha, this is a negative value, so this is your maximum. So your maximum occurs at 2a on 3. So, and what's f of 2a on 3 to? So 3 over a. So let's write that. Your coordinates are, yeah, so your coordinates are 2a on 3, 3 on a. Done. And let's just show some working out, just to make sure that we're being safe to get the mark. So f dash of x is equal to what? It's equal to negative 81x 3x minus 2a all 4a to the power 4 equals 0, blah blah blah, and we solve them. Done. Find the x values of all points of intersection between the graph of f and h in terms of a. Okay, easy. So we want to solve where f of x is actually equal to h of x, comma x. And these, we want the x values. So these values. Done. So that's right. So x is equal to 2a on 3. X is equal to a on 3. And x is equal to 0. Done. Determine the total area. Determine the total area of the region bounded by the graph of y equals f of x and h of x. Okay. Well, I don't know how they look, so what I'm going to do is control and just make a new problem here instead of problem. So we don't want to mix those values up. So if I come and redefine them over here, these values over here, and create a new graph. So let's say that's f of x over here, and put a slider, and g of x over here. I meant h of x. Okay, and we said that a must be greater than 0, so let's put it like here. Okay, something like this. And let's zoom in. Okay, perfect. So, okay, so this is not too bad. So we can say the integral from 0 to this value here, which should be a on 3. On the upper functions, the line, so h of x minus f of x, and then the other one for this one too. So let's do that. So we say that the area is 0 to a on 3. The upper function is h of x minus f of x dx plus, well, I think they're equal by symmetry, but I'm not too sure. Wait, they are equal, aren't they? Yeah, because they have the same, it's just double the amount of this value over here. So can I just say twice? Area is twice this, yeah? Is that a smart way? Let's do that. So, so we're saying, well, no, we're going to do it over here. So yeah, we're saying twice 0, a on 3. Oh, no. Yeah, I'm hoping that's right. If they should be equal by symmetry, but 1 on 8. Is that right? Let's double check it. So let's do the long method too. So just to be safe, bring this over here, plus integral for this. Let's copy this actually then. That's 2a on 3, 2a on 3, and the next one was f of x minus h of x dx. Okay, 1 on 8, so they are equal. So let's write that, 1 on 8. That's that. Consider the function g of x by this, where a is a positive real number. Evaluate this. Okay, so g of x is this function, so let's write that. So let's define that. G of x as 81 x squared times a minus x for a to the power of 4. Done. So we want to evaluate, all right, 2a on 3 times g 2a on 3. That's 2, so let's write 2. Find the area bounded by the graph of find the area bounded by the graph of the inverse of g, the x-axis, and the line x equals g on 2 and a. So wait, let's find g on 2 over a. Well, this equation over here. It's 3 over a, so we're just saying what's x3 on a. Okay. Yeah, let's find the inverse using LCAS. So we know how to find the inverse. It's just solve g of y equals x comma y. Okay, that's why it's one of those last questions, because it's very hard because they give you so many functions. So what I'm going to do is I'm going to sketch it actually. I'm just going to sketch it. How? Well, let me just take that g over here and bring it over here, and define it. And let's just get rid of these actually. And let's put this. Oops. Actually, this. Okay. It's this. Okay. So we're putting this, and we know, let's say a equals 2 because a is greater than that. And what else can we say? Well, we're saying if we draw x, the line y equals x. Okay. Is that okay? So equals 3. The inverse. So if I'm just going to sketch this, let's sketch it on my diagram over here. So this is how the graph's going to look. Well, we only need the positive, so let's just draw this here. Okay. So we'll have this graph going like this and like this, going down. And we can draw y equals x by a red graph, so something like this. And so the inverse would look like this. It will look like this inverse. Okay. So 3 on a. So we set the line. So we go menu, entry relations, x equals 3 over a. Where does that occur? So 3 on a. If I, let's say, take one of these over here, this point here, really sketch it. Y equals that. Okay, take that out. So that x equals 3a is, like, this is not a full complete, but let's actually complete it by just taking all of these actually. Oh my god. Okay. Oh. Let's just take this actually. Y equals. Let's take that also out. What's happening here? Okay, this is a mess. I'm not gonna lie. This is a mess, so I'm just gonna take these all out. Okay, so we just need that. So I think this thing just touches the max, this max point. So if I'm looking at my graph over here, that point over here, this point is, if I go down, this point over here is 3 over A. So 3 on A. Okay. So it means this over here, this point over here, by inverse properties, should be 3 over A. Okay. Alright. So, and I'm trying to calculate what area. So find the area bounded by the graph of the inverse, so the green graph, the x-axis, and the line this. 3 over A. So I'm trying to find the area this. Well, we're trying to find the area of this point. Wait. Find the graph of g of x, the x-axis, this, and the line this. So we're trying to find this area over here. Alright. This is the area that we want to try to find. Well, well, actually, I'm just trying to think. If this is this point, 3 on A, 3 on A, this point over here is what? And this point, what's this point 2? So, okay, if I know... Okay, let's just say, if we want to solve this point, so solve where g of x equals 3 over A, comma, x. Okay, 2 over A, so 2 over A. So this point over here, oops. Damn, this is too much for this question. 2A on 3. Then this one's supposed to be a 2A on 3. And we want to calculate that. This is actually a pain. Just trying to think. For such, how many marks? 2 marks. And yeah, this is the last. Okay. So, let me just use this. Oops. And let me just make it small. Okay, so we wanted that area, so how can we take it? If we want the area, that area is the same. Okay, wait. So that area, if you really look at the symmetry over here, we want this area over here, yes? That area is equal... that area is equal to this area, if I'm not mistaken. Yeah? Is that right? Because it goes like that, and so we're going like this. Yeah. We want this area. That area is equal to this area. So, if I can find the area under this graph and find this rectangle, like this triangle, rectangle, the area of this whole rectangle, which is what? 2A on 3 multiplied by 3 on A, that's the area of the rectangle, minus this area over here. So it's from 0, 3, 2A on 3, g of x dx. That's that. Yeah. I hope that's right, man. Oh my god, what a question. What an actual rubbish question for a last... I don't know. I gotta double check my answers, man, after I finish this video, because Not gonna lie, this is my first time doing this exam, so I may have mistakes, but I hope I'm doing it right. Because, yeah, I'm just trying to use my calculator. It makes even everything harder. Bring this over here. G of x dx. 1. So the area is 1. Yeah, it looks right. Yeah. It looks like for a hard question, they would give such a rubbish 1. Like, that's what they always do. They're for the last questions. The complexity of the question is hard, but the simplest answer is the answer. Like, it's the simplest answer they give. Okay. Find the value of a for which the graph of g and the inverse have the same endpoint. So, we know that this is the endpoint for g, yeah? From 0 to 2a, which is... Yeah, so we're saying this is this. So this is the endpoint. So if I'm going to be honest, if I can, let's say, rub this out. So we're saying if I rub this out, this endpoint. So if I rub that out, by symmetry, this endpoint should be also rubbed off. Yeah, so this rubbed. So if we want that, we want to find the value of a for which this had the same endpoint. So to do that, we just equate this to this. Because, yeah, they have the same endpoint. So we want this endpoint and this endpoint to be the same. The symmetry, yeah. So what's 2a on 3 equals 3 on a. I'm just going to do all my calculator. My brain's not working. Solve 2a, this equals 3 on a, comma a. And we get two values. Okay. Well, a is greater than 0, so a can only be 3 root 2 on 2. I think I took too long on e, so... Find the area enclosed by the graph of G, again. Find the area enclosed by the graph of G and G inverse when they have the same endpoint. So, okay. Find the area. So now because we know the value of A when they have the same endpoint. So what I'm going to do is, I think I can do this on calculator. So if I can come back to my calculator and say, this over here, now because I know the endpoint, the value of A, which is what? 3 root 2 on 2. Okay. This looks alright because I have symmetry. If I can find the value from 0 to this value over here, which I don't know. Yeah, I don't know what value is that. But I do know that to calculate this point over here, it crosses x. So what's this graph, the blue graph, which is what? G of x. So we can say G of x. Yeah, so if we go on G of x equals x. And we know we've already given a value. So we want a to be this value over here. And we want to solve that, comma x. So, okay. So it means these are our actual ends. So that's from 0 to this value over here. So if we say that 0 to this value over here, what's the upper function? The red one. So no, the red one is your actual inverse. Okay. Oh my god. Damn. All right. This is not good. I don't have the function of the inverse. So, what can I do now? Well, this makes life even harder now. Find the area of enclosed by G and G when they have the same endpoints. So, if I want this area, what can I do? Oh, okay. There is a way. Because, oh my god, this is good. Because you see the graph x, if I say x minus the blue graph, which will give me this, we twice it to get this. And then again, twice this whole area to get this also. Yeah, that's good. Oh my god, I'm so happy. I'm so actually happy. So, if I say from 0 to this value of x minus g of x, comma x. Yes. Yeah, so that to that. and we want to twice it, yeah, we get this. And we know the value of a, luckily still. The value, oops, the value, what's happened? Oh, the value of a is this over here, 1 on 8. So 1 on 8 is this area over here, and we just twice it to get the other area. So 1 on 8 times 2, 1 over 4. Yeah, so area 1 on 4. I'm not gonna lie, I'm gonna have to check my answers, because I don't know, man. This exam felt difficult. Like, it didn't feel difficult, but the last question is, I think I may have made some mistakes. I don't know. I gotta double check the answers. Yeah, I hope I went good. I hope I, didn't make too many mistakes in this exam. I will have to check my answers, and yeah, I hope you guys enjoyed this video and learned something. Damn, this exam, I'll be honest, I'll rate it. I personally did not like it. Like, I don't know, man. I've seen better exams, but yeah, this exam was like, I'll call it a mid. I'll rate it a 6 out of 10, I'll be honest. But yeah, had all right questions, but yeah, now I'm going to go to sleep because I'm very tired. I hope you guys enjoyed the video. Please make sure to take care of yourselves and have a good day. Bye-bye.